Welcome back. In this section, we finalized our understanding of algorithms with dynamic programming. And we've completed all of this. And now, the very last piece of the puzzle is complete. Dynamic programming, and specifically using memoization to optimize our problems, completes our entire diagram, our mind map of how to master the interview. So what did we learn? We learned that with dynamic programming, we can identify these types of problems by first seeing, hey, is there a problem that can be divided into subproblems of smaller pieces, where most likely you're using recursion. If you're using recursion, then ask yourself, are there any repetitive subproblems or tasks that I'm doing over and over? In that case, we can memoize these subproblems so we don't constantly recalculate things and use this idea of dynamic programming so that we get a nice raise from our boss because we just made the code so efficient. Now, memoization is a common strategy for dynamic programming problems, which are problems that I just described here, such as the Fibonacci problem. There is one other way of incorporating dynamic programming, and it's called bottom-up approach. And we won't focus too much on it, but I want to show you quickly how it might look like. In our case, there's actually a third way to solve this problem. And the way to do it is, well, it's actually fairly simple. We can do Fibonacci master 2. And in this function, we'll have the answer, which will be the list of our Fibonacci sequence, which is right up here. And we're going to pre-fill it with 0 and 1. And then from there, all we do is a for loop and say, let I equal to 2, because we're now starting at the second index. I is less than or equal to the number n. And we'll increment I. And then finally, we will say answer.push. And we'll push to the next item in this stack the results of the first and the second. So I minus 2 plus answer I minus 1. And then we can just return answer dot pop, which will give us the very last item in the list according to what index we're looking for. So that if I run this and call it dp2, I should still get, and I have to make sure that I pass in, let's say 100. If I run this, there you go, we get both of the same results. And this type of approach avoids recursion. Some would say is not as clean, not as easy to understand, while others will say, no, this makes a lot more sense. It really depends on your preference. And this type of solution is called bottom-up because you start from the simplest solution from the bottom and slowly work your way up higher and higher towards more complex problems. But these types of problems, although easier to see, are harder to figure out when to use. So I prefer the top-down memoization approach of using this. But I just want to show you that there is another way of doing things. And in an interview, it's very rare that you're going to be asked to implement both methods. But at the end of it all, I hope you see the power of dynamic programming, this simple concept of saving ourselves a lot of trouble thinking about how our programs run and how we can optimize it so that we don't do any repeated tasks. If you're able to notice these things, then you are a great engineer. I'll see you in the next one. Bye-bye.